Hi everyone, welcome back to our channel. Today we are going to solve problem number 66. So this is nothing but the problem on transient. For the given transient circuit, initially the switch was at 0 minus for a long time. So here the long time is nothing but t is infinity and it is closed at t equal to 0. We have to obtain the equation of I of t for t greater than 0. I mean at position 2 we need to find. So and obtain I of t for a time interval at t equal to 0.25 second. Okay. So now you can see here the inductor is charging. The expression of I of t is nothing but, so let's try to understand. Now this is the source and the switch has been moved. So this is the position of the switch in position 2 and we are going to have the resistor as well as the inductor. Okay, so now it is excited with a voltage of 12 volts and a resistance of 8 ohm and an inductance of 10 Henry. Okay, so now the inductor starts charging with the polarities of positive and negative. So therefore, the expression of I of t is equal to, we are going to get it as V by R into, it is getting exponentially charged. So V by R into 1 minus e to the power minus t by tau. Tau is equal to, here the time constant, tau is equal to L by R. So substitute this. So therefore, you are going to get, when you substitute tau equal to L by R, so then you are going to get as L divided by R. So this is what we need to find out. Therefore, I of t is equal to, what is the applied voltage we are applying is 12 volts divided by R. What is the resistance of the network? 12 by 8 into 1 minus e to the power minus t divided by L by R. L value is how much? 10 divided by 8. So 10 by 8 if you perform, then this is nothing but the expression of I of t is equal to 1.5 into 1 minus e to the power minus t, which is nothing but 0 0.8. So when you bring it to the numerator, it's nothing but 8 by 10, which is 0 0.8. So this is the expression for I of t. And the second question asked is, obtain the equation of current at t is equal to 0.25 seconds, which is 1.5 into 1 minus e to the power minus t. T is 0.25 multiplied with 0.8. Just use your calculator, then you can get it. So the expression for at I 0.25 seconds, we're going to get 0.27198 ohms. Okay, and the third question asked is, so find the time constant at t at one time constant, which is nothing but L by R. So the value of L is 10, the value of R is 8, where you are going to get a time constant of 1.25 second. So the expression of I of 1.25 is equal to, so 1.5 into 1 minus e to the power t. T value is 1.25 into 0.8. So this is the expression you are going to get, and you are going to get 0.948 amperes. Okay, so these are the different currents we are getting. Let's try to draw the waveform. Okay, so now when you try to draw the waveform, so this is nothing but t and x-axis. This is how the current is varying with respect to t, and it maintains a magnitude. You see here. So slowly it, this is nothing but 1 minus e to the power t by t. So the inductor gets exponentially charges. Okay, this is how the inductor is charging, and it reaches the peak value. This is nothing but the peak value of current is 1.5 amperes current, and so this is the peak current at t equal to 0.25. So the current is how much? 0.27. Okay, so here you are going to get, so current, this is the current at a time of 0.25 seconds. You are going to get the current as, so this is the current of 0.2719 ampere. So this is that magnitude of current 0.2719 0.2719 ampere and zero point 0.9. So here you are going to get 0.9. So draw a vertical line. So this is the time interval at t equal to one time constant. The one time constant is we already calculated, which is 1.25 seconds. Then you are going to get this instant, and this is a peak. So here you are going to get the current of at 1.25 you are going to get 0.94. So this is how the inductor slowly charges and it reaches the steady state. So up to 4 times the time constant. This is only one time the time constant. So up to 4 times the time constant. So this is a 4 tau. So we can write down 4 into 1.25 second. So which is approximately we are going to get as up to 5 seconds. So this is the duration up to 5 seconds. The inductor is in transient state. After this state, we have only steady state. So this is completely steady state. So this state we are going to call it as steady state. The inductor has reached steady state. Where this state we are going to call it as transient state. So this is how to draw the expression of I of t, and transient state is available for a time of 4 times the time constant, and steady state will be available after t equal to 4 tau. So this is the time constant at 4 times the time constant. This is how transient state after 4 tau mean more than 4 tau, 6 tau and so on. Okay, so you are going to have the steady state. So this is how to calculate the expression of I of t for the circuit shown. So it was here we have to consider that the initial current is 0. Why? Because at t equal to 0 minus there's no it is the switch is open. As soon as the switch is open, the initial current across the inductor is 0. That's why we no need to consider. Hope you're able to understand. If you feel my explanation is good, please like the video and share with your friends who are studying the same subjects. And if you have any doubts in this explanation, just make a comment. I will answer your doubt. And if you're watching the channel for the first time, subscribe to my channel with the name KB Tulasiram. Thank you for your time. We'll meet in the another video. Yours Ram.